Okay, question 10 is a differential equations question. It says that we've got a spherical mint with a radius of 5 millimeters. 4 minutes later, the radius of the mint becomes 3 millimeters. The rate of decrease of radius. So it says you should define the variables used. So r is going to be the radius in millimeters, and t is going to be the time in minutes, because those are the values they've used in the question. We've got minutes and millimeters. So the rate of decrease of radius is dr by dt. It says is inversely proportional to the square of the radius, so it is equal to negative k over r squared, and I've done a negative k because it's decreasing in radius. We then need to solve this differential equation and use the information that we've been given to work out the value of k and work out the constant of integration that we're going to get. So we need to get the r's together on one side, so I'm going to have r squared dr is equal to negative k dt. Then we can integrate both sides, and this is going to be r cubed over 3 is equal to negative kt plus the constant of integration. So important that you remember that. Okay. It says initially when it's placed in the mouth it is 5 millimeters. So when t equals 0, r is equal to 5. So 5 cubed over 3 is equal to 0 plus c. So c is equal to 125 over 3. So we can improve our equation, and we can say that r cubed over 3 is now equal to minus kt plus 125 over 3. The other thing they told us that 4 minutes later the radius is 3. So when t is 4, because my time is in minutes, when t is 4, r is 3. That's going to allow us to get k. So 3 cubed over 3 is equal to negative k times 4 plus 125 over 3. So that's 9. 9 is equal to minus 4k plus 125 over 3. K is going to be equal to 9 minus 125 over 3 divided by negative 4. Which is 49 over 6. So then we can say finally that the equation is r cubed over 3 is equal to negative 49t over 6 plus 125 over 3. Let's times everything by 6 to get rid of all the fractions. When in fact, what did it want? It just says find an equation linking radius to time. That would actually do then, but I don't like the fractions, so I'm going to times by 6 and get 2r cubed is equal to minus 49t plus 250. Okay, hence find the time taken for the mint to completely dissolve. That will be when the radius is equal to 0. So 0 equals minus 49t plus 250. That's going to be t is 250 over 49. Which is 5.10 minutes. It wants the answer in minutes and seconds, so that is that's going to be 5 minutes and 6 seconds. limitation question. A limitation of the model of sucking a spherical mint at a constant rate. All of the things I've just said there are quite unlikely. You're unlikely to carry on sucking the mint at a constant rate. It's unlikely to stay spherical. Loads of other things you could say. Either of those two that I've just said. I'm gonna go with the mint is unlikely to stay in a spherical shape. As I said, you could also have had the rate of sucking might change. You might eat them in, you might crunch them in. You're not necessarily going to stay sucking them in until it dissolves in your mouth. Anything like that is absolutely fine. It just had to be a sensible limitation of the model.